This video will cover chapter 11. So we used to cover the three variable systems in a lot of detail, but we have really kind of moved away from that at this point because calculators and matrix solvers do a lot of the heavy lifting for us. And so we really don't cover it anymore. It's never really on the final. So we'll just kind of breeze through that and then focus more on the nonlinear systems. So to start, there are two ways to have a solution set for a 3 by 3 system. You'll see that right here visually. Some people find it to be really helpful to see this version of it. So notice that all of the colors must overlap in some way at the same time. If you do not have that happen, you're going to run into a situation like this, where in this situation, two colors overlap, two colors overlap, and two colors overlap, but all three do not overlap at the same time. Same situation here. And then in this one, there is no overlap. Okay, no overlap at all. Now, we'll do this example where we have to confirm or deny that one of these, that this ordered triple is going to be a solution to the system. The best way to do that is to just plug in those points and check and see if they equal 2, 31, and 13. All three of them must work in order for this to be an ordered triple. So let's just go ahead and start with the first one. We have 3 minus 2 plus 1. Is that equal to 2? Yes. We have 6 times 3 minus 4 times negative 2 plus 5 times 1. Is that going to equal 31? Yes, it is. Then we have 5 times 3 plus 2 times negative 2 plus 2 times 1. Is that equal to 13? Yes. So that means the ordered triple is the solution. Now, I'm going to do this one example to show you what this would look like when it's done manually, but again, this will not be an expectation of you on the final in any capacity. I'm going to start by looking at equations 1 and 2. If I look at those two, I immediately notice that if I were to use the elimination method, x would easily go away. So if I add this all up, I end up with 0 for x, and then I end up with y plus 2z equals 3. So that works out nicely. Then I need to do the same thing for another pair. So I'm just going to use equations 2 and 3. Now for 2 and 3, if I want to get rid of x, I need to multiply this equation by 2 in order to get negative 2x and positive 2x. That's going to be negative 2x plus 6y minus 2z equals negative 12. So that's this new equation. So now I'll go ahead and subtract. So that gets me 0, 1y, 3z, and 5. Now I have two equations with two variables. I can solve by substitution here. I'll go ahead and set one of these equations equal to y. We'll take this one just because it's right there in front of me. We have y equals 5 minus 3z, which means instead of having y in my equation, I'm going to have 5 minus 3z plus 2z equals 3. And that's what I need to solve. I'm going to come down here. So we have 5 minus 3z plus 2z equals 3. And that's going to be negative z equals negative 2, or z equals 2. Now we found one of our three values. Once you found that, you can go back in and find the y value from y equals 5 minus 3z. I'll go ahead and plug in the 2, and I'm going to get negative 1. So now I have two of the three, and I can go all the way back to the beginning and solve for z. X minus 2y plus 3z equals 9. I'm going to find x, so I have x minus 2 times -1 plus 3 times 2 equals 9. And now we just solve for x. I'm going to have 9 minus 6 minus 2 going to equal 1. So now I have all three values for my ordered triple. So 1 comma -1 comma 2 is the solution for this system. What we're really going to focus on is solving nonlinear systems. When you're solving a nonlinear system, it really works similarly. You just need to try and isolate a variable when possible and solve. So in this case, I'm going to bring this x over and set this equal to y because I have a y here. So I'll go ahead and replace it with x plus x squared plus x plus 1 in parentheses squared equals 25. I'm going to go ahead and factor, or not factor, distribute, and I'll have x squared plus 2x plus 1 equals 25. So now we're just going to go ahead and combine like terms and factor. This all shares a factor of 2, and I'm just going to divide it out because, you know what? Why not? Work smarter, not harder. After factoring, I'm going to get my x values, and I'm going to see, whoops, that my x values are going to be -4 and 3. Now I can go back in and plug them in my equation to find y. So y equals -4 plus 1 or -3, or y equals 3 plus 1 or 4. So my final answer is going to be -4, -3, and 3, 4. Those are going to be the two solutions to this system. Now, that's going to happen because one of these is a circle, right? This one is the circle, and then the one underneath is the line. So there's going to be two places where the system intersects. And we found those 2 points. Moving on to the next one. This one is actually already set up for us to easily replace y squared. We already have a function, we already have the equation equal to y squared. So let's just go ahead and replace y squared in the first equation with x plus 5. We'll have x squared plus x plus 5 equals 25. Just like last time, we end up with a quadratic. So I'll go ahead and go through those steps really quickly. We've done this a ton now, so you are probably also breezing through it. And I'm not going to talk through all those steps this time. From here, we found our two x values. Now we just want to plug it back in and see what the corresponding y values are. So I'll go ahead and use y squared equals x plus, and we'll plug it in. Y squared equals -5 plus 5, or y squared equals 0, or y equals 0. So that's one of them. And then we have y squared equals 4 plus 5, or y squared equals 9, or y equals plus and minus 3. Okay, I just want to point that out. That's important. There are two solutions because this for a square root, there are always a positive and a negative. So in this case, we have 3 points of contact, and they are -5, 0, 4, 3, and 4, -3. Taking a look at this last one, we'll do something similar and go ahead and isolate one of our variables. So I'll go ahead and rewrite this as y squared equals 4 minus x squared. Doesn't matter which one you isolate, but we'll just go ahead and isolate y. And then we'll replace y squared with 4 minus x squared in the second equation. And now we want to distribute and simplify as needed. So go ahead and do that. And now let's just combine like terms as needed. So we have 7x squared equals, let's do that math really quickly. 44 minus 36, 108. Okay, dividing by 7, I believe is going to be a decimal. So I'm just going to roughly estimate here 15.4, and that's squared. And when we take the square root, we're going to have positive and negative, roughly 3.9. From here, let's go back and solve for our corresponding y values. So I'll just go ahead and use y squared equals 4 minus x squared. And I'm going to move up here. So for positive 3.9 and for negative 3.9, we have y squared equals 4 minus 3.9 squared. And that's going to get us, let's find out, 4 minus 3.9 squared, negative 11.21. Now, when you take the square root of this, you end up with imaginary numbers, which means no solution. Let's try with the other one and see if we do have an answer there. So we have 4 minus negative 3.9 squared. That actually ends up being negative 11.21 as well. So it's the same situation and there's no solution. Now, if you were to put this in a graphing calculator, you would see that I'm actually going to use the same colors so you know what it's going to look like. So it looks like this. The reason they are not going to touch is because it's a circle inside of what we call an ellipse. So there is no overlap. There's no spot where any of these are going to touch. And so that's why you're starting to get those weird numbers and imaginary numbers because there's no solution. So that can happen.